Okay, YouTube, this is my last video on operating with complex numbers, in which we're going to focus on how we divide expressions that are complex numbers. And there's actually a special technique that we use in order to evaluate operations such as, say 5 plus 4i divided by 4 minus I. And so what we're going to do is we're going to borrow from a property of multiplying by conjugates that is always true in algebra. But let's go ahead and observe what happens when we multiply what we refer to as complex conjugates. Now remember, when you have two, say, binomials that are conjugates of one another, we say that they're identical in every way except for the middle sign here. One is going to be positive, the other one's going to be negative. So if we carried out this FOIL here, we would get an a squared, so the first number times itself really, and then we would say, well, I'd get a positive or a negative abi, and then followed by a positive abi. These middle abis are going to cancel out as a matter of necessity, and then we would say that the final term here would be positive bi times negative bi, which is going to give us a negative b squared I squared. And recall that when we talk about an I squared, we're really squaring the square root of negative 1, which just comes out to be negative 1. So that being said, really what happens is, instead of getting a difference of two squares, we get a squared minus b squared, we really get a squared minus b squared times a negative 1, which really makes us an a squared plus b squared. So this is unique in that you see no i's whatsoever. There are no imaginary units in this. So this would be a purely real result, okay? And that's kind of an important thing, because what we're going to be doing is trying to get rid of this I that is in the denominator, say over on this expression here. So let's go ahead and wrap up what we just observed. We see the conjugate of a complex number. We say complex conjugate of the number a plus bi is a minus bi. And the complex conjugate of a minus b is a plus bi. And the multiplication of complex conjugates gives us a real number, purely real result. So we'll always end up with some a plus bi times its conjugate, being a squared plus b squared. So when we look at this expression over here, I'm going to go ahead and rewrite it down here. We have 5 plus 4i divided by 4 minus I. What we're going to do is we are going to multiply the top and the bottom by the conjugate of the denominator. It is always of the denominator that we want to multiply by, the conjugate. So we would say, really, we'll go ahead and rewrite this as times 4 plus I over 4 plus I, which is really multiplication by 1. And it is worth noting that at least in the denominator here, our a value is 4 and our b value is negative 1. The reason why I mention this is because you can certainly go ahead and FOIL this out. We watched how to multiply complex numbers in the last video, but it's not worth your time when really what you know you're going to get is 4 squared, really 4 squared, plus, it's going to be plus, and then we'd say in this case negative 1 squared. I know that we have to get this. Now as far as what that simplifies out to, we know that 4 squared is 16, and 1 squared, negative or positive, is going to be a 1. We are going to end up with a 17 in the denominator. Now as far as what we get on top though, we actually do need to carry out this FOIL up here. So we get 5 times 4 is 20. 5 times I is going to give us a 5i here. 4i times 4 is going to be a 16i. And then last but not least, a 4i times an I is just going to be a 4i squared. So a couple of things I want to do here. First one is this. The 5i and the 16i, we're going to go ahead and combine those. So I would get 21 i's here in the middle. I'll rewrite my I. There we go. And then we're going to get plus. Now remember, I squared is negative 1. So we get plus 4 times negative 1, which really is negative 4. So when I add that negative 4 to my positive 20 here, what we end up with is a 16. So 16 plus 21i. Now, I'm going to put a box around this, but the last thing I want to mention before we leave this video is this. We want to write our answer. So it says express your result in standard form. What that means is we want to write this number in a plus bi form. And you'll notice that the box that I put right here is not the same as this box over here, okay? So what I'm going to mention here is this. I'll make a little note. We say that 17 is a monomial divisor. That is, if you ever have just one thing in the divisor, what we can do is we could rewrite this initial expression as everything on top over this 17 individually. So that is, we get 16 17ths, in this case plus, now 21, and I'm going to write 21 17ths, and I'm going to throw the I off on the side. But this would be in standard form, because now we can identify that at least with this quotient of the two complex numbers, the A part, or the real part, is 16 17ths, and the B part, or the imaginary part, is 21 17ths. So that is how you carry out complex number division. You multiply the top and bottom of the expression by the conjugate of the denominator's expression. Cheers.